Hello and welcome back to 600X and our examination of ways to misuse statistics. What we have here is a pile of garbage. I'm using it to represent what is perhaps the most important thing of all to remember about statistics. Garbage in leads to garbage out. This observation is so common that it has an acronym that's widely used, and that's GIGO. Essentially, all this is saying is that if you start with garbage, no matter how good your statistics, you'll end up with garbage. Let's look at an example. The 1840 U.S. Census showed that insanity among free blacks was roughly 10 times more common than among those who were enslaved. The conclusion, at least to some, was obvious. As U.S. Senator and former Vice President and future Secretary of State John C. Calhoun put it, the data on insanity revealed in this census is unimpeachable. From it, our nation must conclude that the abolition of slavery would be to the African a curse. Never mind that it was soon clear that the census was riddled with errors. As Calhoun, by the way, this is what Calhoun looks like, and if you ask me, looking at this picture, he must have been the one who was insane. At any rate, never mind that it was soon clear that the census was riddled with errors. As Calhoun reportedly explained to John Quincy Adams, there were so many errors they balanced one another and led to the same conclusion as if they were all correct. What's wrong with this reasoning? Well, what's wrong with it is Calhoun is assuming that the errors are independent. If we try and state this in a more rigorous way, what he seemed to be saying was that the measurement errors are unbiased, independent of each other, and very importantly, he's also saying that they're identically distributed on either side of the mean. That is to say, he's assuming that we have a bell curve or something like that, and therefore the mean is actually a good representation of the whole. In fact, in this case, it was later shown that this was not true, and that the errors were so heavily biased that no valid conclusion could be drawn. Of course, Calhoun was in office over 150 years ago. Today, I'm sure no politician would ever abuse statistics through either willfulness or ignorance. Another common statistical error goes by the Latin name cum hoc ergo propter hoc. Statisticians, like attorneys and physicians, often use Latin for no obvious reason other than to confuse. In plain English, this phrase means, with this, therefore because of this. One of my favorite examples is based upon the statistical fact that college students, including MIT students who regularly attend class, have higher average grades than students who attend class only sporadically. Those of us who teach these classes would like to believe that this is because the students learn something from our lectures. But alas, one cannot reach this conclusion from this data. What one needs to keep in mind is that correlation does not imply causation. The fact that good grades are correlated with class attendance doesn't imply that class attendance causes good grades. It's at least equally likely that these students get better grades because they're more diligent, and those students who are more likely to attend class are also more likely to study hard. Let's look at another example. This chart shows us the case of flus in one of the U.S. states, New York, in recent years. If you look at it, you'll see that in the summer, cases of flu are low. About September, they start rising, and they stay high through the winter and then taper off again as the summer approaches. People have also observed that if you draw a curve of when schools in North America are open, it looks pretty similar. People don't go to school in the summer, they start going in September, and about May and June, they start leaving. This has led many to conclude that going to school is an important causative factor in the spread of flu. This might be true, but you can't conclude it based simply on the correlation, which could be just as easily used to justify the belief that flu outbreaks are what caused the school to open in the first place. Or alternative, there might be some lurking variable, something other than opening school or the spread of flu, that causes both. And in fact, as it happens, the flu virus does better in cool, dry air than in warm, wet air. And both the flu season and school sessions are correlated with this change in weather. Falling prey to the cum hoc ergo propter hoc fallacy can be quite dangerous. At the start of 2002, roughly 6 million American women were prescribed hormone replacement therapy, often abbreviated HRT, in the belief that it would substantially lower their risk of cardiovascular disease. This belief was supported by several highly reputable published studies that demonstrated a reduced incidence of cardiovascular disease among women using HRT. Many of the women on this therapy, and of course their physicians too, were taken by surprise later in 2002 when the Journal of the American Medical Association published an article that in fact hormone replacement therapy led to increased cardiovascular disease. How could this have happened? Well, reanalysis of some of the earlier studies showed that women undertaking HRT were more likely to be from groups with better than average diet and exercise regimes. That's to say there was a lurking variable, diet and exercise. And in fact, it seemed in retrospect that taking HRT and improved cardiac health were coincident effects of a common cause. The flaw in these studies was in part based upon yet another statistical problem, and that's what's often called non-representative sampling. In this case, the women sampled did not represent women at large. As we have said many times, all statistical techniques are based upon one assumption. The assumption is that by sampling a subset of a population, we can infer things about the population as a whole. If random sampling is used, one can make precise mathematical statements about the expected relation of the sample to the entire population, as we've done earlier in the semester. Unfortunately, many studies, particularly in the social sciences, are based upon what has been called convenience sampling. This involves choosing samples based on how easy they are to procure. For example, why do so many psychological studies use population of undergraduates? Because so many psychologists work on college campuses, and there's nothing easier to find on a college campus than an undergraduate. A convenience sample might be representative, but there's no way of knowing whether or not it is. Consider this example. This is a picture taken of a World War II fighter plane. During World War II, Allied planes typically flew from England over Europe and were shot at by the Axis powers using flak. And an Allied plane would return from a mission over Europe. The plane would be inspected to see where the flak had impacted. Now, what would you do with that information? Well, some thought that the right thing to do was to look where the flak hit and reinforce those areas of the planes that seemed most likely to be hit by flak. Stop for a minute and think about what's deeply wrong with this. What's wrong is that they did not inspect the planes that didn't return from the mission, perhaps because they had been downed by flak, and perhaps because they were hit in the places where the flak would do the most damage. This particular kind of error is called non-response bias. We sometimes rely on non-response bias in course evaluations, which is of course why we'll do our course evaluation at the end of 600X, so we only get responses from those who thought the course was worth sticking with.